to a large storage pond where it will be held until the growers draw it for irrigation. 20 million gallons a day, 22 million gallons a day, every day during the growing season. Probably starting right around March, all the way through October, first week of November, you have this water being treated, this tertiary step here. I say just during that time because during the off season, we have been discharging it out into the bay because we didn't know what to do with it. But, go ahead.
Would we have some residual chlorine in the water? Average plants or?
That's a good question. You do have residual chlorine in the pond. We actually want some residual chlorine in the pond because we want to keep the pond clean. You know, we don't want bacteria growing in the pond. But here's the thing about chlorine. It's very volatile, you know, and it will off-gas given enough time. It's been determined, calculated, by the time that the water gets to the crops, most of the chlorine is dissipated. We go out regularly and sample water from these pumps to make sure that the chlorine is dissipated. And if it is too high, then adjustments are made over here to bring the levels down.
And that's what's coming out of the purple pipes.
That's what's coming out of the purple pipes. Exactly.
So what do you use that bathing for?
With the what?
What do you use that bathing for?
That's where the contact with the chlorine takes place. Mm-hmm.
Are organic farms using that too?
Don't know. Locally, do we have organic farms locally? I don't know why they wouldn't, because there's really nothing wrong with the water. And it was tested extensively prior to the building of the plant. They set up several fields where they would water, some of it with just regular groundwater, some of it would be watered with tertiary water, and there really was no difference. In fact, tertiary water is probably a little higher in nitrate, so it grew a little bit better, but they didn't see any repercussions. And so far, I mean, this has been going on for 15 years, and we really haven't heard any sign of bacterial contamination taking place from the water. I mean, from animals locally, sure, but not from the water. Yeah.
So is that a reason that when the water is not clean? Like, you know,
No. That's a different, that water is completely different than what you have coming out of the tap. Completely different source.
So what happened when we have E. coli on the salad?
That's probably a result of unsanitary conditions at the plant. You might have animals that maybe have been on the field, on the crops or in the crops, but no, it's not from the water. Now, one more thing. Let me say one more thing about what we're doing now. Because of saltwater intrusion, the goal is to kind of slow that down, which we certainly have done, but now push it back, okay? So there are meetings are going on now to take the water that is produced during the off season, so December, January, February, take that water and inject it back into the ground. So we put it back into the water column and it pushes out the salt water, pushes the salt water back out to sea. But that means that water then may someday end up as drinking water, because we still draw drinking water up out of the ground.
Before the chlorine contact basins, so that before that's done, so that one is just the sand.
These are sand filters, yeah.
Okay, so what you just said was, now before you said in winter the treatment process ended at 2%.
At the secondary, yeah.
Yeah, and then the water was discharged in the ocean, but now you're injecting water that they weren't.
Not yet. They want to. We're talking about it. They really want to. You can go to meetings now, public meetings, to discuss the injection of tertiary treated water into our water column, into our groundwater.
So the water that's being pumped in the pond, would they then take that and inject it in the ground?
Yeah, that's probably where it would come from. Because they're really going to have some kind of holding place for the water after treatment. Now, if we go further south, down in San Diego, where water is a much scarcer resource, if you will, they're actually contemplating taking tertiary water and after a series of treatments that might involve reverse osmosis, using it for drinking water. So there's really a push to do that. Yes?
So is this tertiary process like maybe one of the reasons why like the short of water and aquaculture is happening?
Because of what?
Like agriculture, like the water cuttage that they're having, do you think it's maybe because of the tertiary process? Like is it an expensive process?
No. Well, it might be an expensive process, but this is actually reducing the demand for groundwater because we're using the tertiary water instead of putting it out into the bay. So it actually reduces the demand for groundwater.
The third phase starts from sand filters.
Yeah, the third phase starts after the secondary treatment, after the secondary clarifier, where we've slowed down the water and we've let the sludge settle out.
One more question.
Sure.
In that secondary clarifier stage, that's the stage also where it's reducing BOD?
Well, in the clarifier, no, because in the clarifier, the BOD's already been reduced. So let me run through this diagram for you real quick one more time. So we've got the water coming from the house, goes through a crate. Then the water comes into a primary clarifier, and if you remember, that's where a lot of the big stuff settles down. Then the water goes from the primary clarifier to the trickling filter tower. And so from the trickling filter tower, where biological treatment takes place, it moves to our activated sludge tank. Okay, now here we're injecting oxygen. So we got bubbles and stuff, so we're aerating the thing, enhancing the microbial growth. Again, biological treatment going on, reducing BOD. These are the two largest BOD reducing processes in the treatment. Trickling filter tower and activated sludge, because the microbes are actually breaking down the organic matter. Now, we've got a lot of microbes still in this water that's coming out of the activated sludge. So we take it to our secondary clarifier, which is no different than our primary clarifier. It just allows the water to slow down, or slows the water down, lets the organisms that were there settle out. And now you've got an effluent that could go to the ocean, or could go to sand filters, chlorine contact basin, pond, fields. So this is the direction during the growing season. This is tertiary treatment. And this is the direction when we're not irrigating. Now, a couple of things we want to step back and take a look at. We've got a lot of organic matter built up here. Remember, the first primary treatment was a gravity fed situation, and we let the big stuff settle down. So this is a lot of organic matter, a lot of, we call it at this point, sludge. And then we've got a little bit of it building up over here. Now this stuff here is also sludge, but a lot of that sludge is organisms that have come from the activated sludge tank. So some of this we will bring back into the activated sludge tank just to keep this seeded with organisms, just to keep this seeded with protozoan and stuff, bacteria, break that down. But a lot of this sludge we just want to get rid of as well. So this sludge and this sludge are brought to what is known as an anaerobic digester. An anaerobic digester now is a huge concrete tank, if you will, that the sludge gets pumped into, and it is maintained at a temperature that will facilitate bacterial activity. And we actually have a community of bacteria here that are breaking down the organic matter. You got some bacteria that break down the organic matter, and they'll produce CO2 and or they'll produce an acid, acidic acid, and CO2. And then you've got some microbes that'll break that down, and then in the last step of the breakdown are methanogens. Using the CO2 and the H2 that are being produced by the organotrophs in here. So the organotrophs are working to break down organic matter, but their byproducts then are being used by methanogens, and these methanogens are producing methane. And so the methane that is being produced from the anaerobic digesters now can be used in a cogeneration plant to generate electricity. And so our treatment plant right now is running off electricity that is generated from the methane that is produced from bacteria in the anaerobic digester. How many people are on septic? Nobody? Few maybe? Well, let's just briefly talk about a septic system, because you may find yourself in a septic system someday. A septic tank really works very much like an anaerobic digester. You basically have a big concrete tank that's put into the ground, and this concrete tank usually has a couple of baffles that might be placed in it, and then there is an inflow pipe and there is an outflow pipe. The water comes in, and this baffle serves to force the water down into the tank, and so it causes it to mix. What happens then, and we're talking about stuff that you've flushed down the toilet or down your sink, is that the heavy material, as in the case of our clarifiers and stuff, settle down at the bottom. The light